Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Return to Limitations by MD88 Keys, or as I like to call them, Dr. Piano. Here are the rules. We have normal Sudoku rules apply and the clues are standard. So normal Sudoku rules apply means you need to place the digits 1 through 9 in every cell. In every cell you need to place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box in this case. We have limitations where digits may not repeat on any clue from the same rule, which is 1 through 6 below. For example, a digit on one thermometer may not be used on a second thermometer. So there are no repeats on cells which are on the same clue. So for example, we see black Kropke dots here. So the same digit cannot appear in these two Kropke dots as these two Kropke dots. Obviously, that's normal by just normal Sudoku rules. But they also cannot appear in these two cells here. So say we had a 6 here. You cannot have a 6 in any of the other black Kropke dots. So this could not be 6 and this could not be 6 because of that. And that's how limitations work. Here are the rules that you have limitations on. Black dots connect digits in a 2-to-1 ratio. So, for example, if this were, say, a 4, this would have to be a 2 or an 8 to maintain the 1-to-2 ratio between them. We also have white dots connect consecutive digits. So, for example, if this were a 6, this would have to be a 5 or a 7 to make sure that these digits are consecutive. Adjacent digits on a green German whisper line have a difference of 5 or more. The line you see first does extend at least into the 2 diagonal cells. So this is a German whisper line, or as I like to call them, a whisper 5 line. And for example, if this were a 3, these digits would have to be 8 and 9, because those are the only digits which are 5 or more away from 3, which they have to be on a German whisper or whisper 5 line. Rule 4, or clue 4, we have an X connects two cells that sum to 10. So for example, if we had an X here and this was a 6, this would have to be a 4 because these two digits would have to add up to 10. Digits on a thermometer increase from the bulb to the tip. So say we had a thermometer going like this. You could have something like 2, 3, 5, 7, 8. And this would be valid because it's continuously increasing from the bulb to the tip. You could not have something like 2, 3, 5, 9, 8 because you're decreasing from this cell to that cell. And that's going to the tip. And that's not allowed. And finally, as clue 6, we have digits on a purple Renban line form a consecutive set in any order. So for example, if say you had a Renban like this, the values could be something like 2, 4, and 3, and that would be valid because they form a consecutive set, 2, 3, 4. What you could not have, and I think you can't have something like 3, 4, 6 because that doesn't form a consecutive set. I also think you can't have repeats. Technically this, I don't know, 3, 4, 3 is technically a consecutive set, but I don't think that's allowed. That's not normally allowed on Renbans. And we'll assume that that's not allowed here, but we won't necessarily assume that right now. Anyways, those are all the clues. And finally, the grid is partially covered in fog. Placing correct digits may clear fog somewhere in the grid. So this is dynamic fog of war. So you don't necessarily get a clearing of fog if you place a digit correctly. Which is, I'm not a big fan of that, but we'll see how it goes. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, the digits which can be next to a black Kropke dot are the digits 1, 2, 2, 4, 3, 6, and 4, 8. There's no other possible combination of two digits which are in a 1 to 2 ratio. So, these all have to have distinct digits because of the limitations rule, right? Digits may not repeat on any clue from the same rule. So we're guaranteed 1, 2, 3, 4, 6, 8 here. So this must be 5, 7, or 9. It cannot be 5 because 5 can never be on a German whisper line or a whisper 5 line. Because why? Subtract 5 or more from 5, you get 0 or less, which is not a normal Sudoku digit. Add 5 or more to 5, you get 10 or more, which is not a digit. So this is why this cannot be 5, and this can't be 9 because it's in between two white dots. And the reason why you know that is because 9 can only be consecutive with one digit, and this digit is consecutive with 2. So this has to be one unique digit, shall we say. So therefore, this must be a 7, and this must be a 1, 2 pair here to be consecutive with it on the whisper 5 line. It's also 7's only consecutive with 6 or 8. So this is 6 or 8. That eliminates these possibilities of being what? You cannot have 3, 6 be the pair. You can't have 4, 8 be here. You could technically have 2, 4 be here, but then the problem is the remaining digits in for the limitations would be 3, 6, which is a 1 and 2 ratio, and 1, 8, which is not. So this can never be 4, 2 either. So this has to be 1 and 2 here. Not 2 and 3, 1 and 2. That eliminates 1 and 2 in the rest of the column. So the remaining digits in column 5 are 3, 4, 5, and 9. Well, we have, okay, so on a whisper 5 line, you'll always alternate between low digits and high digits, because what digits can be next to a low digit, which is 1 through 4? 4 can be next to 9, 3 can be next to 8 or 9, 2 can be next to 7, 8, or 9, and 1 can be next to 6 through 9, which are all high digits, 6 through 9. So this is high, which means these are low. And if you look at the opposite, it works that way too. These must be high, and these must be low. Not high, these are low. Well, we already have a 1, 2 pair on the whisper 5 line. And by limitations, these digits cannot be 1 and 2. Well, the only low digits left are 3 and 4. And those digits can only be next to 8 or 9 on a whisper 5 line. So this becomes an 8, 9 pair. We have a 3, 4 pair here and an 8, 9 pair, which eliminates 3, 4, and 8, and 9 in the rest of the row. So this can't be 3, 4, or 9. It must be 5, which eliminates 5 in the rest of the column. These digits are consecutive, and these digits are consecutive. We have 3 digits consecutively in this set. It cannot be 6, 7, or 8 because of the limitations rule set. Can't be 9 then. So it's either 5, 4, 3, 4, 3, 2, or 3, 2, 1. But if it's 5, 4, 3, or 2, 3, 4, that would eliminate all possibilities for this cell here. So this has to be 1, 2, and 3, which eliminates 3 here. So this is 4, which can only be next to 9 on a whisper 5 line. So this is 9, this is 3, and that's 8. This cannot be 1, 2, 3, or 4 because of the 1, 2, 3 triplet in the column and the 4 in the column. So this is either 6 or 8, which is next to 3 or 4. What are the remaining digits in row 5? Well, one thing I like to do on thermometers is look at the lowest digit, going from the bulb, looking at the lowest digit to the tip. And then going back from the tip and looking at the highest digit, going back to the bulb. And then we can narrow those cells down that way. So let's do that. This can be 1 because that's the lowest digit. This could be 2. This cannot be 1, 2, 3, or 4 because of the 1, 2, 3 triplet in the column and the 4 in the column. So this is at least 5. And this must be greater than 5, so it has to be 6 at least. This is 8 at most because it can't be 9 because of the 9 in the box. This is less than that, so this is 7. This is less than that, so this is at least 6. This is less than that, and it cannot be 5, 4, or 3, so this is 1 or 2. So this is 1 or 2. This could be 2, 3, 5, or 6. This could be 5, 6, 7, 6, 7, 8 as possibilities. Here, this again could be 1, 2 because it's greater than that digit. Cannot be 3 because of the 3 in the box. So it could be 4 because it's greater than 2. And this digit has to be greater than 4. So it's at least 5. This is at most 9. This can't be 8 because of the 8 in the box. So it's at most 7 because it's less than that digit. This is at most 6 because it's less than that. This is at most 5, but it cannot be 3, 4, 5, or 9. 3, 4, 5, so this must be 1 or 2, which makes this 2, 4, 5, 6, 4, 5, 6, 7, 5, 6, 7, 9 as possibilities. Well, we have a 1, 2, 1, 2 pair in row 4, which eliminates 1 and 2 in the rest of the row. That leaves a 6, 7 pair in the row. Okay. These digits are consecutive. And we cannot have 1, 2, and 3 on them, or 6, 7, and 8. That means 9 cannot be here, because 9 is only consecutive with 8. And it's either 4, 5, it has to be 4 and 5. It cannot be 6, 7, or 8, or 1, 2, 3. So this is a 4, 5 pair, which eliminates 4 and 5 in the rest of the column. This can't be 4 or 5. This is 6 or 7. This digit must be greater than that, so it's at least 7 or 9 here. Okay. This can't be 3 or 4. And again, the remaining digits for the black Kropke dots is 3, 6, or 4, 8. So this is 6 or 8 also, and this is 3 or 4. Remaining digits in row 2. We have 1, 2, 5, 9 remaining. But we have a 1, 2, 1, 2 pair in this upper central box, so this can't be 1 or 2. Therefore, this is 1 or 2, and this is 1 or 2, which makes this a 5, 9 pair. That leaves the remaining digits in this upper central box as 3 and 4. So this is 3 or 4, and this is 3 or 4 here. Okay. Remaining digits in column 2 are 5 through 9. Okay. Oh, this digit has to be a 2. Because you have a 1, 2, 3 triplet. 1 and 3 are only consecutive with 2, so then this would be 2. Which makes this 1, which makes that 2. This is not 2, this is 1 or 3. These digits must add up to 10, and you can't have a 1 or 2 because of the 1, 2 pair in the row. So this has to be 6, 7 with 3, 4. Well, if this were a 3, 6 pair, the problem with that is that it would eliminate 3, 7 as a possibility and 4, 6 as a possibility. So this cannot be 3 and 6, then this must be 4 and 8, which makes this 3 and 7 to add up to 10. This can't be 7 or 8. This can't be 7 or 8. This can't be 7 because of the 7 in the column. That means this can't be 6 because it must be smaller than that. This can't be 4 or 8 here, so this is 3 and 6 here. That eliminates 6 here, so this is 7, which makes this 9. This can't be 7. This pair must be 1, 9, or 2, 8. It cannot be 3, 7, or 4, 6 because of the 3 and the 6 in the box. This can never be 8 or 9. So this must be 1, 2, with this being 8 or 9. These two digits add up to 10, and it cannot be 3 and 7. You can't have 1, 9, or 2, 8 here because of the 1, 2 in the box. So this must be a 4, 6 pair, which eliminates 4 and 6 in the rest of the column. This can't be 4, this is 3, which makes this 4. This can't be 6, so this must be 7, which makes that 6. This can't be 4 because of the 4, 6 pair in the box. This can't be 2, and we already have a 3, 7 here, a 4, 6 here. This can't be 2, so this must be 1, 9. Which means this can't be 1, 9 because of the limitations rules, so this is 2 and 8. Which makes this 1, which makes that this 2. This 8 eliminates 8 here, so it's 6 and 8. This can't be 6 because of the 6 in the row. What else do we have? This is 2, this is 2. So these have to be consecutive. You don't have 5, 6, 7. It could be 8 and 9 if this is 8 and this is 9. You can't have 4 either, so no 4, 5, 6, 7. So it's either 8, 9, 1, 2, or 2, 3. Cannot be 1, 2 because that would eliminate all possibilities for this cell. But it could be 2 and 3. Okay. This is a Renban, and it cannot have a 3 because of the 3s that are in both columns. So it has to be it cannot include 1 and 2 because that requires a 3 for a 4-length Renban. So it would have to be at least 4, 5, 6, 7, 5, 6, 7, 8, or 6, 7, 8, 9. So it's guaranteed to have a 6. Right? It has 4, 5, 6, 7, 5, 6, 7, 8, or 6, 7, 8, 9. It's guaranteed to have a 6 and a 7. 6 cannot be here because of the 4, 6 pair in the column. So 6 has to be somewhere here on this Renban, which eliminates 6 in the box and 6 in the column. So this can't, this can't be 6. So this is 8. We have a 5, 9, 5, 9 pair in column 2, which eliminates 5 and 9 in the rest of the column. So this can't be 5. This is guaranteed to be 6, so this can't be 6 here. This 8 eliminates 8 here, so this cannot be an 8, 9 pair then on this Renban, so it's 2 and 3, which eliminates 2 and 3 in the rest of the column, so this can't be 2. This is 1, that's 2. Where is 7 in this Renban? It cannot be here because of the 7 in the column, so it has to be one of these digits here. So this is a 6, 7 pair. We are guaranteed a 4 here because where is the 4 in column 3? Cannot be in these cells because of the 4 in the boxes. So this has to have a 4. So this is a 4, 6, 7 triplet, which means it must be with 5 here to form a Renban. So this is 5, which makes this 9, which makes that 5. This 9 eliminates 9 here. We have a 2, 3, 4, 5 quadruplet in row 5, which eliminates 2, 3, 4, 5 in the rest of the row. This can't be 2, 3, 4, 5, it's 1. That leaves this digit as an 8 because of the 4, 6 pair in the row. This 1, 9 pair eliminates 1 here, so this is 3, which makes this 1. That 1 eliminates 1 here, so this is 2, which makes this 1. This 1 eliminates 1 here, so it's 9 and 1. This 2 eliminates 2 here, so this is 3 or 5. Okay. We have a 2, 3, 2, 3 pair in the central box. That eliminates 2 and 3 in the rest of the box, so this is 4, which makes this 9. 4 eliminates 4 here. The rest of column 5 is a 3, so this is 3. The rest of column 6 has to be 7, 8, or 9. This can't be 9 because of the 9 in the row. How about the remaining digits in column 8? We have 2 and 9 remaining. This can't be 9 because of the 9 in the box, so this is 2, which makes this 9. Okay. Remaining digits in column 3. We're missing 1 and 5. 1 can't be here because of 1 in the box, so this is 5, which makes this 1. 5 eliminates 5 here, so it's 3, which makes this 2, which makes that 3. 2 eliminates 2 here, so it's 5, which makes that 4, which makes that 5. We have 8 2s. We know where the last 2 has to be. It has to be here. That leaves the remaining digit in this box as a 6. The remaining digit in row 6 as a 7. Okay. We have 8 1s. We know where the last one has to be. It has to be there. 2, 3. We have 8 3s. We know where the last 3 has to be. It has to be there. 4s. We do not have 8 4s. We still are missing a lot of that. 5s. We're missing a decent amount too. Oh, 5. Where's 5 in row 8? Cannot be here because of 5s in the boxes. Can't be here because we have a 5 on this Ren band. So this must be 5 here. That eliminates 5 from being here, so this is 9, which makes this 5. We should have 8 5s, which we do. We know where the last 5 has to be. It has to be there. 6s, we're not that limited, unfortunately. 7s, we're not. Okay, 7 in row 1 cannot be here because of 7 in the box, so this is 7. We're not that limited here, though. Okay. Remaining digit, so 8s. Where is the 8 in column 1? Can't be here because 8's in the boxes, so 8 has to be here, which eliminates 8 here. Where is 8 in column 9? Cannot be here because of 8 in the box. Can't be here because of 8 in the row, so it has to be here. So this is 8. That leaves the last remaining 8 as being here, because we have 8 8s. Now we have 9s. Where's the 9 in row 1? It has to be here. We have 8 9s now. This 9 forces this not to be 9, so it's 7 and 9. And that gives us all the 9s. So now we probably had enough 7s then. Maybe. Yes. In column 7, where's the 7? Cannot be here anymore, so it must be here. These can no longer be 7. So where is the 7 in column 3? It must be there. And that's all the 7s. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. We should have all the 5s, I believe. We do. So now it's just 4s and 6s. Well, 4 in row 3 has to be here, which means 4 in column 6 has to be here, which means this is 6, that's 4, that's 6, that's 4, which forces this to be 6, and then this to be a 6. And that's a solution. Yeah, fairly straightforward. It requires a little bit of knowledge for all of these rule sets, but it's not that hard to deduce out all this information, right? So, fairly straightforward in my opinion. Yeah, I don't know. I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.